Yes, so this is the agenda we have today, and we will spend approximately 5 to 10 minutes on each section. So without going too far, let's start. So first being connecting PCIe 4 GPUs to your existing infrastructure. And yes, the PCIe 4 GPU brings us a lot of computing capability to the IT world. And you can have access to these powerful devices via cloud providers such as Amazon, they got the AWS, or Microsoft, they got the Azure, or like Google, they got the Google Cloud. But for those people who have built their IT infrastructures on site, in order to enjoy this performance, they will probably have to buy a new server with a PCIe 4 standard CPU, a motherboard that supports it, and of course the latest GPUs. And it really brings us to the point where we have to make this tough purchase decision. We will be looking at aspects such as performance. Maybe we'll look into flexibilities and reliability. And most importantly, we'll be looking at the cost and benefits. Luckily, we're here today to introduce you an alternative solution, making PCIe 4 available without having to replace your existing system, while it fits into all the considerations that are mentioned. So our solution consists of hardware and software features. It includes the Falcon 4010, our latest PCIe 4 GPU chassis, and the H3 Management Center, that is a graphical user interface to control and manage your GPUs. So let me introduce you to the hardware first. The image here demonstrates the features we have within a Falcon 4010 chassis. The chassis can be divided up into two identical halves. There are 4 full width and full height by 16 PCIe slots in one drawer, and these are for the GPUs. There's one slot on the side that is fixed to the host port, and there is also one extra by 16 slots, which is low profile slots for extra devices such as NVMe SSDs or extra host adapters or FPGA cards. So here I'm going to play a short clip to show you the actual appearance of our Falcon 4010. So now we're looking at the front side of the chassis. And this is the LCM. You can check your system IP, error logs here. And you can also reset the chassis to factory default, control your system power, and monitor system temperature over here. And these are the management boards. They get you to access the graphical user interface using a Ethernet cable. Now we're looking at the top side of the chassis. These are the fans we have for cooling solutions. Each fan provides 250 cubic feet of airflow per minute, and you can hotplug the fans for service. These are the two drawers in the back, and the two sensors on the side are to detect whether your cover is on or not. Now let's turn to the back of the chassis. And we can unscrew the handle to pull the drawer out. And as you can see here, there are 4 by 16 PCIe slots in the drawer. These are for the GPUs. A slot will provide 75 watts of power, and the remaining power will be provided by the 8-pin aux power source at back. Also, there are 2 more low profile by 16 slots in the middle, and these are for any other devices you'd like to install. And this is a 2000 watt power supply. There are 2 sets of power supplies for the 2 drawers. Each set consists of 1 plus 1 redundant. And these are the ports for host connection in the middle. it can be configured into 4x4 or 2x8 or 1x16 port. Okay, now let me explain the chassis a little bit more to you. Please look at this diagram. So we have a PCIe 3 standard host, PCIe standard environment host, and a Falcon 4010 chassis connecting to it. So what we have here is a PCIe 4 standard environment within the chassis. Your data will be transmitted and processed by GPUs in PCIe 4 standard performance anywhere within this chassis, despite what your host environment is. And this is what we can also do with multiple Falcon 4010 chassis. With a Mellanox Connect X6 installed, we can achieve PCIe 4 peer-to-peer speed, even across the chassis. Again, it wouldn't matter what your host condition is. Next, we will be talking about utilization of GPU resources. I hope this will better expand how Falcon 4010 addresses the term flexibility. So most IT structures today are set up as the diagram on the left suggested. The servers are separated machines, and each of them contains necessary devices. And then they're connected to each other with Ethernet cables. However, there's a problem with this classical setup. Your GPU performance diminishes as the data travels longer and longer, and the efficiency may decrease due to Ethernet latency. Now let's look at the diagram on the right-hand side. Here, we have a system where resources are disaggregated from the server, and then combined as an external resource pool. Now, we can allocate GPUs to any connected host. In other words, you can adjust computing power to each host dynamically, according to the workloads you have. So, the Falcon 4010 chassis accomplished the physical aspect of the composable idea. Next will be the software aspects that enables GPU management. And for this part, I'd like to show you a quick demo on our graphical user interface and the H3 Management Center, highlighting the GPU allocation and GPU monitoring functions. Let's go to the user interface first. Okay, so we have set up a demo system with one regular server and a Falcon 4010 chassis. And we have installed two NVIDIA P100 and two P400 GPUs into it. Now let's check the GPU connection. And we can see that the host currently detects one P100 GPUs. Great. Now let's go to the chassis management graphical user interface. So let's assign another P100 to the host. We click on allocate button and click yes. Let's wait for a bit. So now the P100 GPU should be working for the host. Let's check it out from the host end again. And we see that the host detects two P100 GPUs. Let's try running GPU performance. And we'll go to the performance page. We'll wait for it to refresh. So look at the readings. We see 14 gigabytes coming out of the P100 GPUs. And we see 27.2 gigabytes receiving from the host. All right, that's it for the demo. We'll go back to the presentation. Okay, so what we have here is an all-round monitor that provides real-time info. And it displays information on not only data rates, but also on thermal, utilization rate, power consumption of your GPUs. And it even shows you the fan speeds. Also, it enables efficient system management. You can do a lot of things with it, including chassis power control, system network settings, user management. You can also sync the time to your system, so you can trace back the event log easier. Next, we will be talking about multiple user management. So in reality, we might encounter the situation where a lot of users are trying to access a lot of devices at the same time. And management will be very difficult under this circumstance. So we've added 2 new features to cope with this multi-user and multi-chassis situation. Let's go to the H3 Management Center and take a look at the features. And you can find them in the setting tag. They are role management and the machine group. Okay, so we thought this would be very helpful when you have multi-user and multi-chassis situation. And what you can do is to define your machine groups and define your user groups and map them together. So we're basically breaking down the entire system into smaller systems so that you can manage it easier. So next, we're going to talk about how we can make the systems more reliable and more productive. So we sometimes encounter server crash, or times where a server is handling workloads that doesn't require GPU. So as a result, your GPU will become idle. What if we immediately move over the GPUs to another host? So we can construct a system similar to a high availability infrastructure using multiple Falcon 4010. Imagine you have 2 hosts. Each of them takes 4 GPUs now. And when one of them does not require so many GPUs anymore, the other host can take over the GPUs directly. Other way around, when one chassis is out of order, your host can share the GPUs in another chassis. And to address performance improvements, we made up this scenario here for you for easier demonstration. So we have 4 render artists and 4 identical GPUs. But we have to make a couple assumptions here. First is that the GPUs are perfectly scaled. Second is that the artists take days off equally. So when all 4 artists working, the GPU distribution will be like 1 GPU for each artist. But when one of them is away or is not doing any rendering task, one of the 3 remainders may work with 2 GPUs. So we get the improvement ratio under this situation, about 1.33. This is derived from 3 workloads, 2 of them rendered at a regular speed, and 1 of them rendered twice faster. And we'll do the same math for the rest situation as well. And if we average all 4 combinations, we will get an overall improvement rate around 1.3, meaning that given a GPU sharing solution, the productivity of the artists would increase by 30%. And the actual improvement rate depends on your usage. And yes, You can build up many different clusters with our GPU solutions. Let's say you have a set that you run regularly. Now you want to start a new project, so you're bringing more hosts to the system. These hosts can also share the GPUs you have, and you can always expand your systems easily with our GPU solution. So here are some key benefits of our GPU solution. First of all, it supports PCIe 4, and it is very elastic to the expansion scales. We have chassis available in different sizes. We have a 4-slot chassis, an 8-slot chassis, a 16-slot chassis. And we are able to incorporate GPU direct RDMA technology, which will make the latency low across chassis. And it is very flexible in terms of GPU allocation. The software feature of the solution makes it easy to manage your devices, even when you have a lot of them. It is also very easy to implement our GPU solution. You pretty much just have to plug it in and it starts working. You wouldn't have to migrate any software or applications to a new server, and that can potentially save you a lot of software licensing fees. That is for today's presentation. If you are interested in our GPU solution, you can visit our official website at h3platform.com. We will post all the Falcon 4010 product-related documents on soon. And you can also check out our YouTube channel for more demo videos. And coming up next, we will run a live demo with NVIDIA A100 GPUs installed into a Falcon 4010. So we'll be showcasing GPU direct RDMA as well as GPU direct storage performance. And that is going to be around September. And the exact time is going to be decided. We will send out invitations once everything is ready, so please stay tuned. Now we open up for questions. Okay, so here we have a question from Cody asking, why do we have this drawer design for our chassis? Yes, so the drawer design is for users to manage their GPUs easier. So by controlling power of the drawers separately, you can plug the drawers safely. The other drawer can still be working while you're working on the other half. Also, you can enjoy the composable idea with only one single Falcon 4010 chassis. Does that answer your question? All right, thank you. Any more questions? All right, then I guess that's it. Thank you very much for participating.